So we have a Great Lake, Allen Lake.
No, no, not Alabama. That's a reservoir. We live by the reservoirs in Washington. All right.
Yeah.
What do you think we're gonna do with that third rock?
Break it down.
Yeah, we're gonna break it down, but let's use that. What's that word that we're gonna do?
Weathering.
We're gonna start weathering, okay?
I broke it into
So let's weathering, right?
Okay, there. Don't crumble them now.
You get bigger rock samples, you have to do a little bit
You can
more
do your
work.
other one. You can do your other color. Just to have some.
You don't have to break your rocks all the way down. Totally fine.
I broke some of my rocks all the way down.
There you go.
I broke all of them.
There you go.
Can we take them off yet?
No.
I'm getting hot in these. It's starting to feel uncomfortable. Starting to feel uncomfortable.
When you first break them, they're really hard.
Yeah. So let's say that these rocks that we found, let's say these are igneous rocks, okay? We're gonna start with igneous rocks.
Which one are you?
Okay, now, the rock cycle, that's what we're looking at here. That word cycle, what shape do you think of when you hear cycle? What shape? Cycle, what shape?
Circle?
A circle. Does a circle have a start or a beginning or an end?
No.
No, it's just always, so like, there's not really like one starting
Like a
spot,
circle,
okay?
right?
So, yeah. So igneous, we're gonna start there. Our igneous rocks, we broke them down, right? And that breaking down, what is that called again? Do you remember?
Weathering.
Weathering, there you go. Alright, so here we go, we weathered it. So weathering, when we weather our rocks, we get little bits of rocks, right? Okay? Our little bits of rock, let's draw one big rock here, right? Okay, little bits of rock, and these are called sediments. Okay?
And also known as minerals too.
No, they're not minerals yet. Now, minerals are made from sediments, but these are little sediments. Well, look at all our little sediments, right?
Yeah,
Now, these sediments, the water comes and the wind blows and they fall down because of gravity and they collect in these places, right? So let's get them all together. Let's collect them all together. Here goes our water. Here goes our wind. Just kind of collect them into the middle of your foil there.
I'm just collecting them.
Collect them in the middle of your foil there. Look at all of our sediments. Oh, maybe a glacier came and picked them all up and dropped them off. Okay?
I'm just doing this.
And we're going to pick up our sediments and we're going to smush them together, roll them together. Smush, smush. So yeah, use both hands, right? My hands are going to be super sticky after this. I should have got gloves that fit my hands. It says one size fits most. I'm not the most. All right. Smash them up, roll them up, smash them up, roll them up. Yeah, use your surface. You can roll it. Doesn't work.
You can
Get
roll it
more,
like
more,
play
add
doh.
more, add more.
You can roll it like play
Here,
doh.
get more, more.
I want to eat all of this.
Yeah, roll it together. So what we are doing right now,
Weathering it?
we are not weathering it anymore because all of our sediments collected and we started getting them together and they started cementing. Y'all know what cement is?
Yeah.
It's what we use out on sidewalks,
Yeah,
right?
and
So,
it's dry to it.
has anyone ever seen cement made? Yeah. How do you make it? Anyone know?
Rock.
Take little bits of rock that look like sand powder, and then you pour some water in it, and then you stir it, and then it hardens into a rock. And that's what this, all of our little sediments that come together, they harden, and that Earth on fire, it does. When this happens, we call this, and we pushed it together, and it's called sedimentation or compaction, right? So compaction. We've compacted it, we've cemented it, now it's cemented. Sedimentation, right? That's a big old word, right? Sedimentation, so now they're stuck together. What do your rocks look like? Can you see all the different parts that you started with?
Yes.
Can you see the different colors?
Yeah.
Oh yeah, so right, so we have this rock, right? And then we have some layers here. Maybe we have a layer there. Maybe we have a layer there, right? If I were to break out my three colors, right? Let's see. Sticky hands. I got some blue, right?
Yeah.
I got some purple. I got some pink maybe, right? And I can see all these different layers in this rock. And this is called a, do you know this? I took all my sediments and I stuck them all together.
I'm not even here.
I think you did. If I had all my sediments, what?
Metamorphosis.
Oh, no, not yet. All these sediments sticking together, and there's three types of rock. There's igneous, metamorphic, and sedimentary. Which type of rock do you think we just created? All these sediments sticking together. What do you think, Serenity? Igneous, sedimentary, or metamorphic? Took all my sediments and I stuck them together to make a... Oh, no. Sedimentary rock. Yeah.
Igneous can also be made like that.
No, you're fine. I'm not judging anyone. We took all those little sediments, and now we have our sedimentary rock. Okay? Now, what rock are we missing? We have our igneous that we started, which we don't know how to make igneous yet. We know how to make sediments, right? By weathering it. And then we know how to make sedimentaries by compacting it and cementing it, making it stick, right? Now we have one more rock. What is our last rock? What's our last rock? What's our last rock? You just said it. Metamorphic. Let's figure out how to make a metamorphic rock, okay?
And I know how to make it.
So, this is what I want you to do. I want you now, you can take your gloves off, put your sedimentary rock in the middle of your paper, or your foil. Take your gloves off.
Can we eat it yet?
Nope. I want you to fold your foil. I want you to fold your foil.
Yeah, let me actually. Just gonna take this off.
Alright? I want you to take your hands. This is not going to
Forget
work
it.
very well
It's
for
okay.
me because
Just
I
hold
have
it.
super sticky.
No, not your hands.
Mine are not. They're just.
Let's start. Go ahead, get those hands going. Get those hands going.
I know you're trying
Okay,
to do.
when we rub together, this is a force called friction, right? And what we are trying to do when we do this friction, what happens to our hands? They get warm, so I want you to get a nice, good warmth, and then I want you to push down on your rock as hard as you can. Push down. You might need to stand up, Mila. You might need to stand up,
Stand
Mila.
up, get some
Stand
pressure.
up, Nick. Come on,
I know
girl.
what we're making. The volcano.
Push.
Push it up and make this crazy rock.
All right. Whew. We're now deep in the earth, and all that heat and all that pressure has pushed on our rock, and we can open it up.
I'll just rip it.
Try not to touch it.
Okay.
Try not to touch it. But you can't eat it, honey.
Yeah, you too.
Nope, and some of the kill on
We might need to leave some of our rocks because our foil might have
Don't put it on the
eaten some
table.
of our rocks, and that's okay.
Can we eat it now?
And when you smush it, yeah, go ahead.
Oh, you can
You have a nice, like yours is smushed so beautifully. Look at that. It's like stated in sections and everything.
I guess you can take it off.
So if you look at mine, do you see how would you describe it? Is this rock pretty flat?
Yeah.
Yeah. Is it kind of zigzaggy?
Yeah.
Yeah. You see you see my purple zigzag? You see my green zigzag? Right?
I see my
Yeah.
white zigzag.
Right? Do y'all see my flat zigzag? Right? So a lot of these rocks, these metamorphic rocks, what they do is, because they get pushed down all this pressure in the earth, right? All that heat down in the earth's surface, you get these rocks that kind of look like, they get like a zigzag in them, or they'll get like a swirl, right? So all this will be rock, right? All this will be rock.
It's a crazy rock.
And then let me get some nice swirls in here, right? So, right? And a lot of these rocks, you're going to see them like kitchen counters. Your granite. Or, yeah, your granite. Your marble. Up here in Pennsylvania, y'all have a lot of slate. Y'all have probably, you see it all the time. It's a nice flat gray rock. Okay? It's really, really smooth sometimes. Okay? Now,
I got kitchen counter.
yeah, we have one of those. get sedimentary to metamorphic, what did we have to do? What did we have to add?
Pressure.
Pressure and
Heat.
heat.
And I know that's form.
Okay?
I know how to make it. You add, it pushes down and it
Now.
makes it stronger.
Oh, we need to make an igneous rock.
How do you make an igneous rock again?
Oh, that's such a great question. So, that word igneous.
Are you going to melt it?
Am I going to melt it? Well, let's talk about the word igneous, right?
Igneous means melt.
Igneous, words like ignite, right? Ignition, have the same prefix igni. Okay, does anyone know what ignition is? When your parents get in the car, they turn the ignition. When they turn the ignition, what does it do to their car? Does it turn it on? Yeah, it turns it on, right? When you ignite something, it means you're lighting something on fire. That word, that prefix igni, I-G-N, means fire. So in order to get an igneous rock, what do you think I need?
We have to warm it up some more.
Yeah, I need fire. So how to get igneous rocks is we melt them. We're going to melt our rocks. So let's see how well this goes, right? So,
What are we going to do today?
I want you to come over, take your rocks, try to peel them off. And if
Gotta
you got
peel off the
foil
rock.
stuck in them, don't worry. I got plenty of airhead rocks that you can walk away with foil free, I promise, okay? Walk over,
I can.
walk around, be careful with the cord. Yeah. Science is not perfect. That's the beauty of science. It's okay to mess up. It's totally okay. Alright, back up.
Oh,
Over else,
it's starting to melt.
On this one?
It's boiling a little bit.
It
Do we
is.
get it yet? No, it's smoking?
There you go. Want to put it here, put it here?
So you can actually.
Oh, it's so cool. Oh, mine.
So now
Oh, mine might not come off anymore.
There we go. Take it.
now that's making like
On the side.
bushy.
Okay.
Go
I'm
sit
making
down.
like
Go ahead.
bushy, right?
This thing, hey, which way should I go?
It's okay. Take it like this on the side. It's not going to be
Go
hot.
ahead, sweetie. Go ahead. You, no,
It's
leave
gonna be a little
your
warm,
foil
okay?
up there. Just go ahead and take up your
The nice thing about aluminum foil is it doesn't stay hot for long.
Do we eat it?
No, not yet. Look at that rock. You got all your little rocklets.
It'll be
All right.
Oh, you're good.
It'll be put,
Thank you.
then I'll be able to get it out easier. Whoa, this one was hot.
On the sides where my fingers are.
Yeah.
Where it's safe. There you go. Can I walk yours over for you?
Oh, mine smells so horrible.
I think they smell really good.
Mine smells horrible.
So our igneous rock, in order to do an igneous rock, we have to heat it up. We're heating it up, we're heating it up, we're getting it hot. It's down in the air surface near the core. It's getting hot, it's getting heated, and then it starts to, what happens when you get things hot?
Melt.
They start to melt. So this is where we get, see where my fingers are? Can you grab right where my fingers are? Here, I'll move my hand so you can grab it. Okay? Okay, watch the cords, okay? When it melts, it turns into liquid, and this is where we get lava. Lavas form like this. So all this lava then starts to cool off, and we get these igneous rocks.
Which are actually basically like lava.
They are lava rocks, yeah. So if I leave it here long enough, if I heat it, and then I get it, I'm going to be able to, it's going to be a lot softer. See how it's now it's more squishy? Okay, now my rock's squishy, right? I'm going to have it's going to be real sticky for you, right? So, now what happens if I start to tear this again? What am I going to start making?
Oh,
If I start tearing it again, what am I going to make?
weathering.
I'm going to start weathering it, and I'm going to make some sediments, right? What if my sediments start to get stuck together? What am I going to make then?
Sedimentary.
Sedimentary rocks, right? What happens if my sedimentary rocks get stuck down in the earth and start to melt? What then am I going to make?
Igneous.
Right. Do I have to go metamorphic? No. Can I skip the whole metamorphic stage?
Wait, you
Yeah,
you
right.
can skip from igneous all the way from weathering to that.
The sedimentary?
Yeah.
You still have to have the little bits, okay? So, This is always happening under our feet, every single day, right? When you get a big rainstorm, what happens to the sand and the rocks and the mud? Do they get carried away, or do you see like a little water path?
Yeah.
Yeah, that's erosion. That's that water taking it away. Hopefully they get stuck somewhere and they make these sedimentary rocks, because these are really great for our houses. Anyone have rocks in their house? Like bricks?
Yeah.
Like most of our houses, like we're in the middle of nowhere, it's made of stones. Our whole house is like stones around it. It's the weirdest thing, because we're from Georgia and you don't do that in Georgia. You get a lot of wood down in Georgia. But there's a lot of rocks in our house, right? Our metals come from rocks. Can you believe that? Our metals come from rocks, right? So your baton stick, that wouldn't exist without these rocks and without these minerals. And you wouldn't be able to twirl, right? Cars wouldn't work, right? You wouldn't have oil or gas, right? So I want to show you all some more rocks and some fossils. We're right on track. All right. So
Daddy, can I get it?
what I'm going to do is I'm going to ask that y'all go to the bathroom. It's right around the corner. Let's wash our hands, because our hands are really, really sticky. Let's leave our little foil rocks. Come over here. So, and then like let's kind of U-shape it so everyone can see. Maybe, oh, then you get front row because you're the shortest guy. And sometimes that pays off. People have to stand behind you. Come up here, Mila. I got plenty of space for you. So, we are going to work our way up to like our minerals. Our minerals are down here. So rocks and minerals. Our rocks and minerals. Rocks you saw we created. They're pretty pure, right? There's kind of like most of them are just kind of one type. Whereas, and they're made of different, they have different minerals in them, and minerals are a little bit unique because of how they're created, okay? So if you look, you can feel free to pick up any of these down, okay? So you can take a look at them, see if you like any of them. This one's kind of cool. We have halite, which kind of looks really shiny.
Oh, it's like a little cube.
What is that? I know a lot of rocks. I don't know every rock. And I take pride in knowing that I can figure out the answer. Let's see, where'd you pull it from? From here, all right? Well, be careful. Don't take these up. So, the plastic one. Okay. I'm not too sure. It came from there. It might be hematite. because of the shininess.
What do you have?
See how it's kind of shiny? We could probably magnet and test it. If it connects to a magnet, then it would be hematite.
That's beautiful.
Look at this rock.
That's a geode. So how that happens? Water gets down there with minerals, and then it hardens inside of rocks, and then you crack them open, and then you see the crystals. It's called a geode. You know what that is? It is amethyst.
Oh, I got this at my house.
You do? Oh, cool. Now this one's kind of cool.
When I take a
This
walk,
is a rock,
when I take
right? You're like, are you sure? It looks like a piece of plastic. This is called mica. So it's called mica. And you see how flat it is? So, and what it does is it does peel this to sheets. So it is a metamorphic rock, that flatness, right? When we talked about that flatness in that rock, right? So this is mica. You want to touch it? Feels weird, right? It's a weird type of rock, right?
Yeah.
It does feel like plastic. It's called mica. M-I-C-A.
Does that have any, like, uses?
Yeah.
Crystal.
What was that?
Oh my
Does Mica
god.
have any uses?
Oh, yeah.
Very few. It's a very soft rock. So like gypsum that we use in like our drywall and stuff, or talc powder. Yeah.
Where did you find it?
Yep. That's probably quartz. So quartz really cool because what they do, gold miners, what they'll do is they'll go into and they'll look for quartz because gold likes to grow or likes to form around quartz. So if you find a big quartz vein, that's what we call big rocks that are connected. They're like, oh, there's probably gold around. And quartz comes in almost every color of the rainbow. Yeah, it's the way the light's reflected. So that is, let's see, that might be, because it's so clear, it's probably topaz. In topaz, this is a neat one. If you heat it up at different temperatures, it turns blue. And then the hotter it is, the deeper the blue is.
I have yellow.
Yep, yellow topaz would be one. All right, so let's move forward, and we'll come back. I'll let you free. Probably malachite. All right, so let's come down here really quick. So these rocks, we don't want to touch every single one of them. So I'll let you know which ones you can touch. Okay, so these three, certain rocks sometimes are dangerous to your fingers. All right, so you want to be careful with them. A lot of the rocks that are around your house are not going to be very dangerous. Okay, so these rocks. All of these rocks are found in Pittsburgh, in the Pittsburgh area. So you have your coal. Where do y'all know coal from? What do you get coal for? Yeah, we use it for burning, right? And like Santa leaves you a piece of coal, if that's, right? So like coal, and this comes from living things. Now coal is also the same, it's made from the same stuff that diamonds are made from, which is carbon. So coal gets down really deep in the earth, a lot of heat, a lot of pressure, and eventually, if the conditions are right, they will turn into diamonds. This is where gold comes from. There is no gold in this, but this is gold ore. So this rock has been cleaned of all its gold, and that's what that looks like. All right. Here's some salt.
I love salt.
Yeah. If I let you lick it, it would taste salty. I'm not gonna let you lick it because I don't want to lick rock in my collection. Gypsum. Gypsum is really chalky, and it's the same stuff that drywall. So this stuff, right? The really soft rock, the walls. That's what this is made from. So they take it, they turn it into gypsum. Yes, sir.
I have some meteorites with this iron ore.
Yeah, a lot of meteorites are made from iron. That's the nice thing. Now this one, we look in here. We got some nice ones in here. We got halite. See how clear that is, right? It does look like ice. It's so clear. Do you see how it cubes?
Mm-hmm.
So that property, when it cuts like that, it's called its cleavage. So how it cuts. So this cuts very square-like. So we don't see a lot of like normal square shapes in nature, but some of these rocks do grow like this. So that's how they form.
At the bottom.
Yeah.
What's this?
This is. Oh, let me read it because it's ilmenite, which I don't know what it's used for. Let's see. It's ilmenite sand. It's titanium ore from Georgia or Florida. So titanium is a type of metal, really strong metal, and this is the leftover dust after they get the titanium out. That's the leftover dust. So it's in here because they don't want us touching it and getting all over our hands. Okay. So, yeah, yep. And then here's our chalcopyrite. Remember it? Remember our pyrite, right? Look at that piece of gold, right? No, just kidding. Just kidding.
It's full gold.
It is fool's gold.
Because you think that it was going to be good because you found it, but it's really but you got.
Now, do you know how to tell the difference between real gold and fool's gold?
No.
So gold is, it is, but so is pyrite. Gold is really soft. So pure gold is really soft. So if you watch from the old movies, they'll take gold coins and they'll bite them and bend them. If it bends, and you know it's real gold. If it doesn't bend, you know it's fake gold. So that's why they bite the coin, because they're testing whether it bends or not, right? Have you ever seen the movies do that?
I want to do
Like give them a gold coin, they're like, all right, like pirates or like the westerns know. All right, these are the ones you don't want to touch, okay? Not all of these are dangerous. Yeah, so there's a good piece of pyrite. So there's that bright, shiny gold. Can you see all this? Right? We have your darker mica. Okay?
Is it blue?
This is gallium. That's the one I don't want to touch. So you can see it's really, really
What kind
silver, really, really shiny. See number 11? Right? It does stain in it. If I get it in my eyes, it'll irritate my eyes really bad, and I don't want that. Yeah, this one, you can smell it. No, it doesn't smell. This is called sulfur. So sulfur is number 16 on the periodic table, big old fancy ones you see in science rooms. It smells like rotten eggs. And you often find it near volcanoes. That's why when you get near volcanoes or you get near places like that, they have that like rotten egg smell. Ooh, it stinks, right? Now,
it also looks like egg yolk when it's cooked.
yeah, it does, right? Now they'll take this and they'll put it into your natural gas. So if you have gas in your house and you ever smell like a rotten egg smell, they do that because gas doesn't have a smell. And they want you to know, hey, I have a gas leak, so you're going to smell that rotten egg. So that's that one. We can touch this one if we want. It feels kind of bumpy.
Wait.
Want to touch it? No.
Can you
don't have
touch this? What type of rock is under? Can you touch that rock? One.
Want to touch this one?
Wait, it feels like plastic. Can I head over to it?
Oh, then you want to touch the sulfur? Want to get rotten egg fingers? Your fingers are not. I got all y'all to smell you though. Look at that. Yes, sir.
How much? 45.
45. I don't know off the top of my head. Once I'm done talking, I'll come over here. There is a guide, like a book that came with this, and I'll tell you. Okay? You like number 5? Oh yeah, that one's a nice one. Right, some of those natural blues. Mhm. 23. Yeah, there's that other type of mica. This one looks more like glass.
Yeah.
See it? Mhm. Alright, let's move down to.
What about 72?
So we're going to go over now. What do we know about fossils? They're old. What do you know, Mila? Can you tell me one fact about fossils? Want to come down here? Do you know one thing about fossils? How do I get fossils? Do you know?
I know.
You want to find out?
I know how to get fossils.
What do you got to ask me? What's one fact?
So first, an animal.
Maybe I'll find out when our lady's over.
Time ago, when an animal would die,
Uh-huh.
and then they would slowly get buried over time.
Yep.
And then their bones would turn into rock.
Yep.
And that's what we find today.
Yep. And that's exactly right. So fossils, all of this, including this, is a fossil, a type of fossil. Now we have this. These are called trilobites. You can touch it. The trilobites are, imagine like, anyone ever play with roly-polies?
Yeah.
Imagine like sea roly-polies. They're like big giant roly-polies that were all over, you can touch it. They were all over the bottom of the ocean. And there was a ton of them. And these fossils are really great because there were so many of them. When we find these in nature, we know that there was probably an ocean where it is, right? So fossils give us a lot of history too. Now, if I were to see this fossil, right, what type of environment do fish? So what type of environment do fish live in? Water. I know there's going to be water in this area, right? So what they do is now, did they find it like this? No, they added some paint because if you were to see real fossils, it would look kind of like that one's a really good one, but like if you look really close, you can barely see his tiny little bones, right? So they add a little bit of paint, a little bit of dye, and go, ooh, ah, right? So you can see really close, see the bones.
Can I sing? Can I tell you about something? My brother loves dinosaurs.
Now, we have all of these, and please feel free to take a look. There's another trilobite if you want to see it. Some coral, so please take a look. You can take the bag, flip it over, see what's inside.
Megalodon.
Here, bring some more over. Here's some fossilized dinosaur poop. If you want to see what fossilized poop is. It's called a corpulite. They really do find it in like...
Oh, dinosaur.
Oh, how cool.
And believe it or not, dinosaur poop is actually very important to find. It lets us know things live there and what they eat. So.
Right.
What is it? Did it have a smell?
No.
Want to find out? No.
Daddy. Smells kind of like. Can we have a little like?
You already did. And then an ammonite. Have you seen the ammonite? Those are really cool.
Yeah. Dad, I can tell you where you can find ammonite.
Okay, where?
Halfway up a mountain. That lets you know that there has been a trench
Yeah.
or a body of ocean.
Oh, didn't you able to see them down there? There's a dinosaur.
Yeah, he loves dinosaurs.
Yeah. You see the shark teeth? Yeah, two types of shark teeth. Got a really big one
They're both
and the itty bitty one.
This one's a megalodon and that
Yep.
one's a megalodon.
Alden, what are you gonna do when you grow up?
Can I touch them?
Hey, what are you gonna do when you grow up?
They're fine.
What
I
are
have
you
to
gonna do
do
when you grow
with
up?
kids, not me.
Yeah, tooth. Yep.
I'm going to eat, when I grow up, eat something that can, somebody that can make a real cook in the book of and give Ashton and I what that can eat.
Wow.
Or what's the other deal with
And
you?
Ned has, I'm going to be, in last I'm going to be,
Nope.
in last class, I yet forgot what I'm going to be.
Very cool.
Paleontologist.
Paleontologist. There it is.
Probably the
Can anyone guess what is a fossil of? Kind of like that. What do you think it is, Ash? Nope.
I know it's this. I know it is.
You want to take a guess for now? No? Want to take a guess, Mila? No? It's okay. What do you think, Adam?
Wood.
It is wood. It's called petrified wood. So, I was holding like this because it's like, imagine like a big old ring, right? And we just took a slice out of it, right? So, this is the wood, the bark. So you can touch the bark if you want. Go ahead and touch it. You want to touch it? It's,
The draw.
yeah.
What's in here?
You want to touch it?
It does. It's a.
So what happens is, like, wood sometimes doesn't fossilize. It has to be in a very unique situation. So this wood fell over, a bunch of water and a bunch of stuff fell on top of it really, really quick and compacted it, and then all those minerals replaced all the soft stuff, making a rock. Okay? So this has to happen very quickly for it to happen, because if you notice, all we're seeing are all the hard bits of animals, right? Like the bones and the teeth and stuff like that, right? So, let's keep on going. So that was rocks. Now fossils. Now let's look at some minerals, all right?
I know.
So, I have this piece right here, okay? Y'all think this is pretty heavy? It's a rock, right?
I would say.
Maybe a little heavy? No? You're shocked. You didn't think it'd be that light, did you?
I thought it would be like.
What do you think it is? I'll bring it back to you guys.
I think it's wood.
You think it's wood?
I think I've seen that in my backyard.
You think so? You probably have seen it in your backyard. You probably have seen it in your backyard, and you probably,
wow.
it comes from trees as well. It is. So when it fossilizes like that, it's called amber, though.
Oh, I can see
So fossilized sap becomes amber. So for us parents over here, right, because us kids don't really know this movie, from Jurassic Park, where the mosquito gets stuck in it,
I think
same
I have
stuff.
an amber one.
Yeah, we turn it into jewelry. You can see this ring right here, we'll turn amber into jewelry because it looks really nice and it's really light.
I have a bee in it. I have a bee in
Mhm. So, we have sap. So you can still find sap in your backyard. When it fossilizes, we call it amber then, right? So this is, it's it.
I know it's like this little like tiny crystal.
Yeah, certainly. You're seeing a glimpse of a geode in there. Yeah.
Daddy,
So this is also another really light rock, and these are great. This is called pumice. You know,
It's also lava rock.
it's a lot lighter than you think it would be, right?
It's also lava
it's
rock.
like,
Pass it down.
it feels.
It feels really rough, right?
It's also known as lava rock.
Here you go. And we got little versions of it, like right here. So I had the pleasure of going, me and my son, we had the pleasure of being able to go to Hawaii during COVID, actually. We went out during COVID and was able to go out there and we were able to get some rock samples that they let us buy. So these come from the volcano on Hawaii. So they just erupted this year. They were in the news for erupting. So these are from actually Hawaii. I picked them up from the volcano myself.
Oh, wow.
And then I had to ask for permission. I had to ask for permission to take them because Hawaiian government don't like their resources leaving their islands. Okay? So, and then we have your amethyst. That's your favorite, right? And amethyst sometimes comes from rocks, so like in nature you would find it like this. It would look like that in the ground. Anything magnificent about that? You're like, no, that's pretty basic, right? Kind of boring. I'm good. I don't want that rock, right? And they're digging and they're tracking, and then they find on the other side, you would have like this inside of this huge rock, right? Would be all these crystals, right? So
you don't like the like this. So it's like it's hard
and there's more part of that rock if you want to see. You can see. Sometimes we get little sneak peeks of what's going on inside. Yeah. Yeah.
Oh, is this amethyst?
That's purple quartz.
What is this? Amethyst?
Yeah.
Have you ever heard of rose?
It's light pink. I have some rose quartz in here. So this is argonite. Look at that crazy shape.
Nice. That's a cool color.
See how it shapes? See how the shapes form differently? Right?
That's why you need this type of stand. You would it? Why?
Just because it's done. You can touch it, yeah. I'll bring it back. Looking at the paper over there, yeah. All you want to touch the argonite?
It's the same. This is this.
Yep.
It's argonite.
Alright, and then, yeah, I'll bring this, I'll probably stop talking and let y'all kind of free explore and I'll answer any questions. The coolest sample I have is this itty bitty sample.